I think it is visible. Can anyone
Yes,
respond?
sir.
Yeah, thank you. Yes. In this class, we are going to discuss what is class and what is object. If time permits, we will see some important types of the operators with example programs. So let us try to understand what is class and object first by taking one real life example. And let us take, we have two students with the name Ramu and Raju. Okay, every student has some properties and every student can do some actions. In my example, the properties these two students has hall ticket number and height. Let us say the student Ramu hall ticket number is 501 and the height of the student Ramu is 5 feet. And the actions can be performed by the student Ramu are read operation and write operation. The Ramu can read and they can do write also. In the same way, coming to the Raju, the properties the Raju has are sorry, hall ticket number and height. The hall ticket number of Raju 601 and the height is 6 feet, let us say. And actions, read operation, write operations can do. Okay. So here the point what we need to observe is we can find some common properties and common actions between these two people, Ramu and Raju. So the common properties they have are hall ticket number, height, and actions are read, write. So these are the common properties of these two students. Now, if you write the common properties and actions at single place, that is called class. Okay, a class is a collection of a common qualities of the objects. Common actions can be done by the objects. That is the general definition. What is object in this example? Ramu is one object. Raju is one object. Okay, these are the objects which has a physical existence. And what are the common properties and actions can be done by the objects is nothing but a class. So you can write class like this, class student. You can give any generic name. These are the properties of students now. So you can give the generic name like students. And can you give the examples for the student if I say Ramu, Raju, and so on, right? Those are called objects. Instance of a class is called an object. See, what are the properties and behavior? You can use the word behavior, action. Those two are valid. So, what are the properties and behavior of the students? If we write at a single place, okay, that is called class. See the definition of the Java class in Java. A Java class is a collection of common behavior or actions. Okay, you may use the word behavior or actions. Two are valid. A Java class is a collection of common behavior or actions and common properties, or you can use the word attributes or characteristics of the objects. That is what we have discussed just now, right? A class is a collection of common actions and common properties of the objects. That is the definition of the class. Or you can say it is a blueprint or a template for an object. Obviously, what are the properties a object has? We are writing at a single place. Okay, that's why you can say it is a blueprint. 1 minute. Yeah, Sino. So if you define the class, you can create any number of the objects. Okay. So in our example, if you create the class student, you can create any number of the objects. Like a class may contain any number of the students. And every student may get the same properties, or nothing but every object can get the same properties what you define in the class. The important point is the class doesn't occupy the memory.
যেটা তো এপিসোড আছে কিন্তু লিভ అయితే এপিসোড
Right. We use some variables to store the properties of the objects. As we covered already, a class may contain properties and objects. So if you want to store the properties, we use variables. Okay. And actions also, no? If you want to implement actions or behaviors, you must implement methods. A class is a group of variables of different data types and a group of methods. So while creating the class, you can take any data type. Suppose if you want to store hall ticket number of the student, that is a number type. You can go for the integer type. If you want to store student name, you can create string type. Depending on your requirement, you can create which data type is suitable to you. You can take that data type. This is very important point. For every object, memory will be created separately. As I said already, while you're developing the code, if you write the code to create the class, the memory is not allotted to your class. When you create the object to that particular class, then only the memory will be allocated. Okay, this is first point. Second point is how many objects you created. For those objects, memory will be created separately. Each and every object maintain its own memory. Now, how to create the class? Very simple. Class is a keyword, space. You must give the class name by following the identify rules. Identify rules means that should not have the space. You should not use keyword name as a class name. You should not use any special symbols. Okay. These are the common rules. You must follow those rules. And observe carefully here. Here we are creating some variables within the class. This is the starting point of the class, and this is the ending point of the class. Within the class, we are creating some variables. Depending on your requirement, you can create variables. How many you want? Okay. Here, these variables are called instance variables. What is the meaning of instance variable is? If a variable is declared within the class and outside of a method. Observe here, if you want to write the method within the class, you can write like this. So these are the variables created within the class and out of the method. Okay. So these are called properties. If you want to store properties, you can create the variables within the class outside of the method. Okay. The next one is actions. Already we covered, no? A class contain properties and you can maintain the actions. You can implement the actions within the class. So what is the topic we need to use to implement the actions of the object? Methods. What is the topic we need to use to implement the properties of the object? Variables. So if you observe, we are using variables to implement or to store the properties of the objects, and we are using methods to implement the actions of the object. Then, as of now, we covered what is class, what it contains. Okay, a class is a collection of the properties and actions. How to write the code to create the class name, and create the block. Within that, you can create variables and methods. Now, next point is how to create the object and what is object. Object is anything which has the physical existence in the world. Actually, the object is nothing but what you observed in the real life. That is called an object. But that must have the physical existence. Okay, object is anything which has the physical existence in the world. If you observe the example what we discussed just now, student Raju, Ram, and so on, some students, they have the physical existence. If you take the student Ramu has the physical existence. You can show that person physically. Okay, that is called an object. One object should be distinguished from other object. Obviously, every object must be distinguished. In our examples also, we have taken two different objects. Suppose Ramu and Raj. They are distinguished. Ramu is one person, Raju is another person. They are not same. Then creating the object is compulsory to make use of member of the class. This is very, very important point. Without creating the object, you cannot use members of the class. What are the members? Already we have seen now members of the class are properties and methods. How to store properties with help of the variables. How to implement actions with help of the methods. So the point is, without creating the objects, you cannot use any variable or any method which are defined within that class. Every object has some properties and behavior. We covered this already, right? Now, see the syntax, how to create the object. Class name. First, we need to write class name space object name. You can give any object name. Okay, object name space. You must use the keyword new here. New is a keyword which is used to create the object at runtime. New is a keyword, and space. You must write the class name again. Parenthesis semicolon. This is the syntax to create the object to a class. So in our example, we created a class student and we have taken some objects, Ramu and Raju, right? If you apply the syntax to our example, how to write the code. See now, student, Ramu, assignment, new, student, empty parenthesis, semicolon. So if you write this statement, with help of this statement, a object is created called Ramu. The Ramu is a object to the class student, and the Ramu can get all the properties of the student class and all the methods of the student class. Okay, when you created the object for a particular class, that object will get all the properties of the students, all the members you can access. As we covered already, new is a keyword, okay, which is used to create the object. And last session already we covered data types. Anyway, now see once again, data types. There are two types: primitive data types and non-primitive data types. What is primitive data type? Primitive data types are predefined, already defined by the developers, by the programming language itself. So these are also called built-in data types, predefined data types, or built-in data types. Primitive data types always start with a lowercase letter. Those are primitive data type. Those are already predefined. Primitive data types are predefined. For that, we are using some keywords. Suppose if you want to use int, you should be right in the lowercase letter only. Okay. All the primitive data types must start with, not only start, complete word should be in the lowercase only. Int, float, char, double, whatever. All those are should be in the lowercase letters only. Every data type have fixed sizes. Already we have seen the size also. For example, if you take character, that takes 2 bytes of the memory, and int takes 4 bytes of the memory, double takes 8 bytes of the memory, and so on. Size is fixed. This is one more important point regarding to the primitive data types. So these are the primitive data types name: byte, short, int, long, float, double, boolean, char. So for each and every primitive data type, internally, Java maintains a class. Remember this point very carefully, very important point. For each and every data type, Java maintains a class internally. That class is called wrapper class. The spell is WRAPPR, wrapper class. byte is a primitive data type. The wrapper class for this data type byte is byte also, but the difference is first character should be in the capital letter. Observe here. Okay. So byte same name, but this is the class name. By this, you must understand when you are working with any class, in that the first character of the each and every word should be capital letter. That is the rule. What I'm saying is a class name, when you are writing a class name, in that the first character of every word should be capital letter. So here we are using only one word, byte. In that first character is B. That should be capital letter. In such a way, we must write the class name. Anyway, these are called wrapper classes. Now see, short is a primitive data type. Wrapper class for this short is short with capital letter S. Okay, that rule is applicable for all, but the difference is, see now, int is a primitive data type, but the wrapper class name is integer, complete name. Okay, you should not write int with capital I. No, the word complete, integer, right? And one more thing is eighth one, char. The wrapper class name is character, complete name. And in the remaining cases, same name, byte, byte, short, short, long, long, same thing. But coming to the character and int, you must write the complete name, integer, and character with starting capital letter. These are called wrapper classes. And one more important property about the primitive data types are, these are the data types that store the actual value directly in the memory. Okay, when you create a variable of primitive data type, those values are stored directly in the variables. What does it mean? See now, these are also called value types. I will show you an image to understand this point. And one more important property of primitive data type is you can store only single value. You cannot store multiple values in a primitive data types. For example, if you want to store single element hall ticket number, let us say, you can store a single student hall ticket number by creating the variable of int type, int hall ticket number assignment 501, let us say. But if you want to store multiple student hall ticket number by using int, can we do that? Obviously no. Okay, you cannot store multiple values in the single variable by using, that is a common property of primitive data types. But you can do with help of the arrays. Arrays is a collection, right? You can store multiple values, but arrays is not a primitive data type. We have seen that hierarchy in the last session. Those are called reference data types. That is a major difference. Remember, value types, all the primitive data types are called value types, where you can store single value and those values are stored in the actual memory location. See, for example, if you write int primitive data type number variable assignment 10, if you write like this, what will be happened internally? Observe carefully. A memory cell is created to your statement, and for that memory cell, for easy understanding or for easy maintenance, we are giving some name. Okay, that is nothing but variable concept, and within that we are storing the value 10. This is about primitive data types. What you need to understand from this, see this. Primitive data types store the actual value directly in the memory. Okay, this image relevant to this point. A memory is allocated, within that only the value is stored. You will get the idea when we discuss about reference type. Okay, the reference type, this will not be happened. Second one is reference type, or you can say non-primitive type. Those two are valid. These non-primitive data types are actually not defined by the programming language. Okay, those are not defined by the programming language. You can create, as a programmer of the Java, you can create your data types. Those are called non-primitive data types. For example, just now we have seen a class name student. Who created the student class? We are creating. Okay. So that is the meaning of this sentence. These non-primitive data types are also called reference variables or object references. Why? The reason is they store the references or they store the memory addresses. This memory address point to the location where the actual object is stored. This is very important point. What we covered in the primitive data types, a memory cell is created. Within that memory cell only, the value is stored directly. Okay. But coming to the non-primitive data types or reference data types, in that a reference is maintained. Reference is nothing but that point something, that point to this memory location where the actual object or where the actual value is located. See now. For example, I am creating an object of string type. Okay. String is a data type, but it is a non-primitive data type. Okay. String is a non-primitive data type. S1 is my object name. Already we covered now how to write the creation of the object. As per that syntax only, we are writing this statement. String class name, object name S1, assignment, new is the keyword, class name is string. And hello within the parenthesis, if you write hello, actually that calls parameterized constructor. But anyway, let me use a simple word. So I'm creating the S1, the value is hello, let us say. Okay. Now see what will be happen here. A memory cell is created. A memory cell is created. Every memory cell has one unique address. Okay. Every memory cell has a unique address in the memory. Within that cell, a value is stored hello. But now, when you created object S1, within that S1, the value hello is not available. Please observe this point. Previously, we created int number 10. Within that number, within that variable number, only the value is available. But here within this S1, the value hello is not available. The string hello is not available because this is a non-primitive types. Now see, it points something. It points to this memory location where the actual value is available. It gives the reference. That's why these are called references type. Reference types, non-primitive types. It gives some reference. Now observe here. What is this? This is memory location. This cell memory location is this one, 100,101. And S1 is the object. It gives some reference. Nothing but it pointing this memory location where the actual string value hello is available. Okay. This how the non-primitive data types works internal. This is the major difference. And here the object S1 stored in the stack, that is one of the memory stack, and this actual value will be stored in the memory heap memory. Okay, this variable is stored in the stack memory and the actual value is available in the heap memory, and from this it points to the memory location. The default value of non-primitive reference variables is null. Nothing but if you create the object, but if that doesn't giving any reference. In that case, you can say that the value of that object is null. Nothing but it doesn't pointing anything. That is nothing but null. Non-primitive types starts with an uppercase letter. Okay. So this is one row. Size of the non-primitive depends on the programmer. Obviously, suppose if you want to store let us say array, you can decide the size of the array. That is depends on your requirement. Okay, that is not fixed. In the reference types, data is stored as an object in heap memory. Just now we have seen, right? The data is stored in the heap memory and the variable is stored in the stack memory. The variable is stored in the stack memory, and from the stack memory, it gives the reference to the heap memory where the actual data is available. So what are the non-primitive data types available in Java? Arrays, strings, classes, object, interfaces. All these are called non-primitive data types. See the complete picture in a single slide. So we covered primitive data types. In the primitive data types, numbers, boolean, characters are the major categories. In the number, again, we have integer values. We can store integer values. We can store decimal values also. If you want to store integer values, nothing but a number without any decimal, without any pointing value, you can go for byte, short, int, long. And if you want to store number which may have the decimal value, you can go for float and double type. Okay. Yes, so integer examples for the integers: a number without fractional value. Float means a number with fractional value. You can store any boolean values, nothing but true or false values. For that, you can use the primitive data types. Boolean character is nothing but only single character, but that should be enclosed within the single quotation mark. So this is about complete picture about the primitive types. Let us discuss very important point regarding to float. See this. It occupies 4 bytes of the memory, common point. By default, all the decimal values treated as double type in Java. What does it mean is, so if you know C and CPP, you can create float data type, right? Float space variable name assignment, any float value that is valid. But if you write the same statement in the Java, you will get an error that won't be executed because by default, all the decimal values are treated as double type. So what we need to do if you want to store any float type, I will show you that. Float can be stored 6 to 7 decimal digits, nothing but a number after the point you can store 6 to 7 decimal digits. And at the end, observe this point, at the end, you must write F if you want to store this value as the float type. If you are not specifying this F by default, that value is treated as double type. That is the meaning of this statement. Okay, as we covered, we need to write F. You may use lowercase f or uppercase f. Those two are valid. See, suppose I want to assign 10.3 as a float value. For that, what is the statement we need to write is float space variable name assignment 10.3 f also. Okay. See this example, you will get the clarity. So here I'm using Visual Studio Code, VS Code to execute the program. If time permits, I will show you how to download, install a VS Code also. See, what is the program we are writing here is class name is float example1 within the body of the class, public static void main string args as usual. Within the main body, within the main method, we are writing like float variable name is var itself, assignment 3.17f. Okay, then I want to print this variable value, system.out.println variable name, that is var. So just execute it. For the execution, you can use this play button. Okay, na? Just like a play, na? Click on that run button and you will get the output. Very simple here. It takes some time if you are executing first time to load the required files. Yes, see now. Right, see, this is our output 3.17. Okay, now see what is the value we assigned to the variable var 3.17 f. But now I'm deleting the letter f and save it. Control S. Okay. Then let us try to execute once again. Now observe it. See the screen. Otherwise, so you will get error if you write the code like this. That is, I want to show to you. Now see, this is the error. If you observe this error, type mismatch. Read this. Type mismatch cannot convert from double to float. What does it mean? By default, this value is treated as double type. Okay. What is the meaning of the error given by the Java is you are trying to assigning this double value to the float variable. That is the information given by the Java for us. So what is the solution? You must specify. You must give the clear information that this is not a double value. This is a float value. How can we give that information? By using f here. Now the meaning of this statement is 3.17 is a float value, not a double value. Now you will get the output. Run it. See, output is 3.17. I think it's clear. This is the important property of the float type. Okay, this is we covered already. See, same program, we are getting type mismatch error because here we are not specifying f. Coming to the double type, if you want to store very lengthy value or more accurate value, you can go for the double type, which takes 8 bytes of the memory, and you can store 15 to 16 decimal digits after this point. After this point, you can write 15 to 16 digits, more accurate value. Generally, this is used in the scientific calculations. And one more important point, we can express double values in the scientific notation also using lowercase e or capital E also. Meaning is, suppose if you want to write 1.5 into 10 to the power of 8, same value you can express like in the scientific notation. The format is 1.5, the same value, but in place of 10 to the power of 8, you can write e power 8. That's it. This is called scientific notation. 1.5 e to the power of 8. The meaning of this statement is 1.5 into 10 to the power of 8. Right? In the same way, if you want to specify negative values also, you can. So 1.5 e to the power of minus 8. The meaning is 1.5 into 10 to the power of minus 8. Negative values. And if you want to specify any value as a double type, you can use dr the suffix, okay? But it is not mandatory because already we covered by default the float values are double type. But if you want to write, you can write, no problem, okay? See this example. Double variable name, var1, variable 1, assignment 62.5. So here I am not using any suffix d. But if you want to use suffix d, that is up to you. This is valid, this is also valid. Actually, these two statements are same. With or without writing the d, they treat same. You can write capital D or small d. Two are valid. This is one more important point. In Java, floating point division operation can return plus infinity when we divide with 0.0. Okay. Any floating value, if you divide it with 0.0, we will get the infinity also. That is very interesting point. I will show you that. So the program name is see this program. Let me execute this. See this very interesting one. The output is infinity. Okay, you will get the output infinity also in the Java. Infinity. That is the output. When will we get the output infinity? If you divide any float value with 0.0, nothing but that is also a float value. Okay, you will get infinity as an output. Generally, in some languages, C, CPP, if you do same thing, you will get an error. You won't get infinity as an output because in those languages we cannot get the output infinity. But in Java, we can get the output infinity. Okay. Then see. Next topic is operators. Let me tell you a few important points regarding to the operators. First, let us try to understand what is operator. An operator is a symbol which is used to perform any particular task or some tasks or operations on values or variables, or you can say operand. Simply, operator is a symbol which is used to perform some action. Okay, that is an operator. If you read 2 plus 3, in this example, generally this is called an expression. Okay. Expression is a combination of operators and operands, where operator is plus. In this expression, plus is the operator, and these two and three, those are called operands. What is operand? Operand may be a value or may be a variable also. In this case, operand is a value, 2 is a value, 3 is a value. These are values. Okay. Already we cover this now. What is operand? The variable or value on which the operator is applied, on which the operator is going to perform, going to do some actions. That is called an operand. Then what is an expression? Expression is a combination of operands, operators, some constants also. Constant is nothing but 2 is an integer constant, 2.3 is float constant, like that. Okay. And all those are arranged according to some syntactical rules of the Java. That is called an expression. See, a plus b, 2 plus 3, a plus 2. These are example of the expression. In this is 2 are variables and 1 operator. And 2 are constant values. Okay. 2 are constants, 1 operator. And in this, 1 is variable, 1 is constant, and operator. Okay. You can create an expression with help of the 2 variables, or 1 is constant, 1 variable, or 1 variable, 1 constant, or 2 constants. All are valid. And one more simple points. If an expression contains only integer values, that expression is called integer expression. And if the expression is contain only float value, that is called float expression. Very simple. See this? Suppose if we write 2 plus 3, that is an expression. Okay. In this, 2 and 3, those are operands. And plus, this is called an operator. So here I am using minus. Okay. In the previous, we are using the plus operator. Here we are using minus operator. And one more change is, in the previous example, we are using constants. 2 are constants. Operands are constants here. In this example, operands are variables and operator is subtraction. Okay. These are operands, where operand is a variable. This is operator, and the operator is subtraction operator in this example. And entirely, this is called an expression. Based on the number of operands an operator works, operator are classified into 3 categories. This is very, very important point. So many people get confused about this terminology. See, how many number of the operands you are using in your expression. Based on that number of the operands, the operators are categorized into 3 types. First one is unary operators, second one is binary operators, and the third one is ternary operators. Unary operator, binary operator, and ternary operator. What are those? See, unary operator means if any operator works on single operand, if any operator works on single operand, it is called unary operand. For example, minus 5. If I write minus 5, minus is what? Operator. 5 is a operand. If you want to mention any value as a negative value, just one value is enough. Minus 5, that is valid. In this case, that minus is called unary operator, unary minus. In the same way, minus 10.5, minus is a unary operator, because how many operands we are using here? Only one, 10.5. Minus a, this is also unary operator. Minus is a unary minus operator, a single operand, right? Then if an operator works on 2 operands, it is called binary operator. For example, if you want to perform any addition operation, subtraction operation, or multiplication, can we implement this with help of the single value? The answer is no, right? Suppose if I write 2 multiplication, can we get any answer? Is it valid one? No, it is not valid expression. If you want to implement multiplication, at least you need to maintain two values. 2 into 3, yes, this is valid. 5 into 7, that is valid. At least two values you need to maintain to implement multiplication operation. So multiplication operator is a binary operator which requires two values at least. So technically we are using the operator which works on at least two operands, which takes two operands. That is called binary operator. Example, 2 plus 3, where plus is a addition operation here, addition operator. Okay, minus, and one more important point. See, here I am using minus, 8 minus 9. Here, the role of the minus is subtraction. But in the previous case also, I am using minus only. But in the previous case, that is called unary minus operator. And here, this is subtraction operator, even though the symbol is same minus. Okay. In the unary case, that is used to represent negativity, negative value. But in the second case, the same symbol is used to implement subtraction operation. Okay. So frequently you may find this type of the things. Same symbol that may be used in the different meaning in different cases. Okay. So in this case, minus, unary minus, it is used to represent negative values. In this case, it is a binary minus, which is used to implement subtraction operation. Okay. So subtraction requires at least two values. If you write minus 9, that becomes a unary minus. Okay, hope it is clear. Then third category, ternary operators. If an operator works on three operands, then it is called ternary operator, or you can use the word conditional operator. Okay, we have a special syntax for the conditional operator or ternary operator. We'll see later on. But as of now, just remember what is operator, what is expression, what is operand, and what are the different type of the operators. Okay, single single operand if you use, that is unary operator. Two operands if you use, binary operator. And if the operator works with help of the three operands, that is called ternary operator. Okay, this is the complete picture about the operators in Java: arithmetic operators, relational operators, assignment operators, logical operators, bitwise operators. Apart from these operators, we have some operators, those categories: unary operator, ternary operator, and some special operators. This is complete picture about the operators concept in Java: arithmetic, relational, assignment, logical, bitwise operators. Apart from these, again, we have some unary operators like increment and decrement operator. And we have the ternary operator or conditional operator. And apart from all these operators, we have some special operators like comma operator, semicolon operator, and so on. Okay. In the next session, we will see the complete operators concept with an examples, arithmetic to special operators. If
Sir,
time permits, yeah.
can you please share today's PDF in the group?
Yes, yes, I will share.
Okay, sir. Thank you.
Any doubts regarding to today's session?
No, sir.
Yes, anyone has any doubts, you can ask. Otherwise, we'll start. Okay, that's it for today's session. Okay, if anyone
Okay,
get any
sir.
doubt regarding to today's session or any completed session, you can ask your doubts in any sessions. No problem. Okay.
Okay, sir.
Okay. Right. Bye.
Okay, sir. Thank you.
Okay, ma. Thank you.